folks, we're going to do something called, we're going to assess a data set to see whether or not it's normal. And the question is the data normal? And so we're going to go through a process by looking at how we could answer that question today. And we'll do that in a minute. But before we get to it, we're looking at the normal probability packet, and I was asked to talk about 3D. Now, in question 3, it says no calculator, no table. We don't use the tables anyway. But if we're not allowed to use a calculator, what's the only way I know to use to find the probabilities? The 68, 99.7 rule. The empirical rule. Okay? So that's kind of what I was expecting you to do in number 3, is the empirical rule. Okay? So if we look at number 3, since you're asked to, we know we have to use the empirical rule, we would simply draw the picture. And I really was looking for several of you, I mean almost on all the problems, to draw a picture to go with each one. Okay? So I'm just going to generally draw number 3, and then we'll be specific to 3D, Sammy, okay? So it says a mean is 50, so I'm going to put the mean in the middle. We always do that. The standard deviation is 5, so if I know I need to do how many standard deviations above and below? 3. So we're going to do 3. So if it's 5, we're just going to go up by 5s, and we're going to go down by 5s as well. Okay? And I'm just going to make my mean a different color so I can really know where this middle point is. Yes? Okay, 3C is the one you're concerned about. Okay. So that's the picture that goes with all of 3. Now, when we talk about A versus B versus C versus D, each of them really have a separate picture. And so Sammy wants to talk about 3C, so we'll look at that one specifically. And this is where I'm going to highlight what it's asking me to do. So in part C, it says, what % of the time? Now, it's always good to ask yourself, are they asking us for a percent, or am I given a percent? Because really, that is the key to know whether I use normal CDF versus inverse norm. Okay? So if they're asking us what is the percent, which one of those two functions am I going to be using? If I'm trying to find the percent, that's normal CDF. If I'm given the percent or the probability, that's when I use inverse norm. Okay? So what % of the time will the crazy car traveling at 50 miles per hour stop between 35 and 55? So this is what I'm looking, I hate when I put 2 fingers down. This is what I'm looking for here, is this part of the graph. And so we just have to be able to find, using our empirical rule, each of the different parts. Okay? So let's add some more to our picture here. This it says in part C. Okay. I think he originally said D and then changed it to C. So if we're looking here, we know how to use our calculator to do that. That's actually kind of an easy one to plug in. But with no calculator, we would have to use empirical rule. So how do I know that this is 34% here? Up and down, how many ups and downs? So within one standard deviation is 68%. And then we have half of that. So you're right. All right? So knowing that on the other side, I'm also going to have 34. Good. So now I just need to find the percents associated with the other two. And they're not 34, because that would give us a lot more than 100, right? Which is not what I'm looking for. So how do I find the next one? What did you do? Okay, so say that louder, Charles.
95 would be between 40 and 60.
Agreed? 40 and 60, I'm sorry. That didn't go far enough. So within 2 standard deviations, we're at 95%. Good. And we're going to subtract off the 68, which gives us what? And we know we're only going to do one of them, because we're going to do half of that, correct? Exactly? I don't know, I'm just asking. 13.5, right? Okay, I just want to make sure. Okay, so 13.5% is this guy here. And we'll use that same logic to do the 99.7. So 99.7, we're going to subtract off what we know, right? And then we'll divide by 2. Okay? So, well, we also know that this one's 13.5, don't we? Couldn't I just do, well, you tell me. There's lots of different ways to go about doing it. So what percentage did you get? Jasmine? Hang on. What's your question, Jasmine? Go ahead. No, I want you to go first. Like I said, there's a lot more ways to go about doing it. I definitely agree with you. So say that louder for all of us. I'm not sure this side of the room heard you. So say it again. Couldn't you just and add 34, this 34, right? That's totally fine. And so what did you get? So 8.35%? Okay. Since it's asking for a percent, I believe, in the question, right? Not a probability. I'm sorry? Oh, okay. No, I'm not. I'm asking for this part right here, just this little part. You didn't do it that way? Okay. I'm sorry. So you meant the answer is totally and subtract off. I misunderstood what you were saying. Yeah. So, but can we just answer my question? How did you get 2.35? I agree with you. Uh-huh. Okay. Good. So this is 2.35%. Okay. And then we'll add those together, and when we do that, you get 83. So, well, since it's asking for a percent, we're going to say 83.85%. Okay. Now, the way I did it is I broke it up by each part, and as Jasmine was talking, there's other ways to go about it. You're just using the symmetric properties of the normal curve. Totally fine by me. I'm good with that, okay? No problem. I'm going to break out here. All right, any other questions that you'd like to talk about? Number 9? No. 3D? Less than 50 or more than 60. Less than 50 is 50%, Kyle. She just threw her right under the bus with that. Do I still need to do it? Okay. Is there any other questions on any other part of the test, I'm not going to do 3A. I'm not going to do all of them because I'm grading this for accuracy. Lindsay. You guys, I can't even hear her, and she's in front of me. Okay, so the extra practice number 2, number 3. Okay? So that's the number 3 on the next page. Well, we're talking about ACT versus SAT 2. Or ACT versus SAT. By the way, just kind of an interesting food for thought. You guys are, at least the sophomores and juniors, the seniors have already done this. Taking both the SAT and the ACT are actually very beneficial. Hopefully you guys have done that. When you are, what is wrong with me? I'm like breaking out. When you're applying to colleges, you obviously want to look at what your colleges accept. And what they take. They're very similar. They test very similar things, but sometimes the results can be better on one versus the other. Anyone find that? Did anyone do that and find that? Where did you do better on, out of curiosity? Better on the ACT? Same thing? So I'm not really sure why that's true, but I know that is a common thing. And you guys do know that the SAT for us sophomores is changing, right? And the writing's gone, and there's going to be a whole bunch of stuff that they're redoing the whole thing. So number 3 on the ACT versus SAT, and I'm not going to do it completely, but I will at least get you started on it, okay? It says the quintiles. Ooh, what the heck is a quintile? Kind of like a quartile, okay? Sorry, I'm just looking at quintile. What do they mean by that? All right, so if any other values with the cumulative proportions, then we have 0.2, 0.4, 0.6, and 0.8. Okay. Why do you think they call that the quintile versus a quartile? Dividing it 100% by 5, right? Quin being 5, right? So quartiles you divide by 4, which is why you have 25% in each of them. Here you have 20% in each of them. That's just all that means. So it says, what are the quintiles of the distribution of SAT scores? Show your method. So these are the percentages, would you agree, or the probabilities. Then we just have to use, so we're given the probabilities. We have to find the actual score, inverse norm. So this is where you would do an inverse norm. You actually need to do it 4 different times. SAT versus ACT number 3. Lindsay, does that make sense? Okay, that's all I'm going to say about that. Anything else I can kind of guide you into the correct direction? Okay, yes, one last one. Same page number 1? Sure. Okay. It says Maria scores a 28 on the ACT. We're given her score. Assuming that both tests measure the same thing, and in theory that's supposed to be true, what score on the SAT is equivalent to Maria's ACT score? I find that an interesting question because there's more than one way to do that. We have two different tests, the ACT and the SAT. They're both normally distributed, but they're 2 different normal distributions. Would you agree? If I'm trying to compare them, we should probably work back to a what? A z-score. So that's really what you want to be thinking about is what is the z-score that's associated with 28? Does that make sense when I say it that way? So the z-score that's associated with 28 would be 28 minus, then what's your mean for the ACT? I can't see worth a darn, y'all. I need new glasses. I can't even see it. Oh, 20.9, thank you. So 20.9, and then the standard deviation was 4.8. So you're going to find this z-score, and you're going to use that exact same z-score, but plug in the normal numbers and solve for x. And then you would have the SAT, which is 1026 and 209. It's because you're a genius. All right. Can I please, I'm going to give you like about 2 or 3 minutes to finalize anything that you need. And in 2 or 3 minutes, I need all of the normal probability packets here, please. So how can we tell whether a data set's normal? We can't use this normal CDF function on our calculator. We can't use the inverse normal on our calculator. We can't do any of that, Tanner. You know why? Because we're not told the data's normal. So what we need to do is we need to check to see whether or not you're like so sick. Go home. What's the matter? You're so hot. You're like really warm, honey. You're like you feel like you have a fever. Can you eat M&Ms?
Yeah. He said he didn't want it.
You need to eat them. You need some sugar, Tanner. You need to increase that blood sugar. Brenda's like, don't accuse me. All right. So when you have your own data, we don't know if it's normal or not. We're hoping, because if we can use this normal probability functionality, then we can find the probabilities of things that would occur. So we're hoping the data is normal, but we can't assume it is. Okay? And even if we graphed it and we got like a unimodal symmetric, we can't assume it's normal without actually conducting this kind of test to see. So A histogram or a dot plot, because we've been doing with the NFL data, right? So a dot plot histogram, something that will show shape, is a good starting point. We're looking for roughly unimodal and symmetric, but as we know, not all unimodal and symmetric distributions are normal. So there's more to the story. So this is like step one. Okay? So if I ever ask you, and I will ask you on your test that you take on this unit, is the data normal? The first thing you're going to do is to graph a histogram or some sort of sketch. I love him. He's putting it on my desk for me. Thank you. All right. So step one, graph it. Now, what can go wrong with the graph? Okay? Obviously, if it's not unimodal and symmetric, what graph does this look like that we've already done? It's skewed what direction? Skewed right. And isn't our right behind above Tanner and Brenda, isn't that NFL salaries, isn't that also a very skewed right distribution? Okay, this is a different one. This is the number of CEOs versus the compensation that they've gotten. Obviously, anyway, it's not unimodal and symmetric. Fair enough. So obviously, you want to check for that first. If it's not, then you can say right away it's definitely not normal. Okay, you don't even have to check anything else. You don't have to go any further. But if it is relatively unimodal and symmetric, we have a semi-decent picture, there are two additional steps that you want to take. And the normal probability plot is the first one. Okay? So what the heck is that, you say? It's a plot that you're looking for. It plots this ordered pair, by the way. Okay? And the calculator has the functionality to do it automatically for us, and I'll show you which plot that is. It's kind of nice, actually. So all we have to do is type in the data, okay, and it's going to find the z-score that's associated with it and plot this point. Now, when we plot this data, okay, these ordered pairs, if the original data is unimodal and symmetric, then these points x, z scores would be a linear relationship that's approximating the line y equals x. So here's what I mean. The normal probability plot that we want to look like would be something along those lines, okay? Probably not. It's relatively linear in the line y equals x, okay? So that's what we're looking for it to do. Here's what some will look like. And that's definitely not, okay? Some of them will look like they're in an S shape. Definitely not, okay? So that would be not normal. So you have to first you're going to look at a histogram. We're looking for unimodal and symmetric. Second, you're going to graph a normal probability plot. And I'll show you how to do that on your calculator in just a second. So we have two plots we're going to look at. If both of the plots look like they model the data, then there's a third thing that we need to do. Okay? So here are some examples of normal probability plots. If you look at the one on the left, obviously the histogram is turned on its axes here. But can you see that the histogram is relatively unimodal and symmetric? Just turn your head to the left. You can kind of see that. Okay? And then its matching normal probability plot is relatively the line y equals x. Would you agree? Straight line. Okay, there's a couple little points down here. And these little guys down here correspond to these guys. And so it kind of makes sense that they might be outliers. Do you agree? They don't follow the same trend. It's still okay. Now, the one on the right, if you turn your head to the left, what direction is it skewed? It looks like it's skewed right. Okay, skewed right. Would you agree? So a skewed right, notice what the pattern now looks like for the normal probability plot. It's more of this S shape. Do you agree? So that would tell me that the data is yes normal or not normal. Not normal, okay? So we would say in this case that this would be normal. Maybe. We would say, in statistics we like to use the word relatively, okay? Relatively normal. This one is just not normal. Okay? Now, how can I take this data a step further? There'd be one more thing we'd have to check. And I'm going to show you how to do that in just a second. Okay? So here are the data of our bags. Before we even get to doing anything, someone tell me Well, first of all, you have your bags with you, right? What does the weight say it should be on the bag? 47.9 grams. All right, so we're talking about average maybe. But if I look up there, well, Charles suggests an average. I think that's a great place to start, and actually it's kind of what I asked you to do. Let's find the mean and standard deviation. Let's start there, okay? And let's see if it's right. Is 47.9 going to be the average? Let's try. Okay, so I calculated it, and I get this information here, and we're trying to find the mean and the standard deviation. I got the mean to be, and it's a sample mean, so I'm going to call it X bar because this is a sampling of the data. So 49.8. Would you agree with that? And then our standard deviation is a sample standard deviation. So that's a notation there. I kind of told you, which one of those numbers am I looking at? 1.77, right? The one that looks like this on the calculator is still a standard deviation, but we call that the population standard deviation. And back when you took Algebra 2, that's the one you were supposed to use. And if you're in IB math, that's the one you use. But in AP, we don't use that one. We consider everything to be a sample. So in AP, you're always going to use the sample standard deviation. Okay, so in this case, we got 1.77. All right, fair enough. So before we answer question 2 and do anything of that nature, is the information printed on the bag the mean? I don't even think it's that close. 47 point what? 47.9, and we got a whole two grams more. All right. So Deja says maybe it's because they're trying to make you feel good. You got more. You beat the system. Da da da. That's good. Give me some other reasonings by why you think this is true. Always happens, by the way. Come on, think. Why do you think the mean that we calculated is more than the mean that's what's printed on the bag? Okay, to keep the customers happy, and I do think that there is some truth to that. But there's one other thing. Okay, now that is. Give me a high five on that one. Okay, that is awesome, what he just said. Not what I was thinking, but still very awesome. He said, well, our sample size is kind of small. And that sample size is going to be everything to us here come soon, okay? And so that is an awesome way that your brain just went. I love that. So we want to think about sample size. Did you get it, Miss Carter?
Round draft pick.
Woo, 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 woo! There we go. Come on. Sorry. There we go. All right, so love the size, okay, I agree. Give me something else. Why is this higher than the bag states? Why is that? Could have, maybe.
On the box, it has a range on it. It says 48 to 47.
No, 48 is a number in the box. Yeah. You scared me there for a minute. I was like, they did? No. There's 48 packs is what she was thinking of. So why do you think I had you keep your bags?
Oh, because the weight of the bag.
Why don't we try to weigh our bags and see what the bags weigh? So if you ripped off a corner of your bag, please just weigh the whole thing. So let's just weigh a couple of them, okay? So do the answers surprise you? So if you took your original weight and you subtracted the weight of the bag, are you closer to that 47.9 range? No? How about this? If we found the mean of this and subtracted the mean of the original and the mean of this, can we just eyeball the mean to be like what, 1.3? Are thereabouts?
Yeah.
So if I subtracted 1.3 from this mean, would I be closer to the mean on the bag?
Yeah.
Okay. So just FYI, the contents is what's weighed, okay, not the actual bag itself. So that what's printed on the package is the weight of its contents, and that's always what's done. But it's still a little bit more, right, on average than what the bag says, and that's probably to keep us happy, okay? So that's a good thing.
I got 45.
Well, that's when you get angry at M&M Mars and say, I didn't get enough M&Ms in my bag, okay? All right, so at this point, what we need to do is we need to decide if the data is normal, and this is what we're going to do. Let's draw a histogram first. So I don't like the calculator's histograms very well because they create the bins, if you remember these terms from the very beginning of school. They create them without any input from us. And so it's not the best picture, but go ahead and try. Do you remember how to draw a histogram on your calculator? Let's remind us. So if you go to stat plot, we're going to turn the first one on, and we're going to go to histogram. We did put our data in XList 1, correct? Okay. And then we'll just go to zoom stat. Remember that? So zoom stat is zoom 9, and this is our picture. And again, it looks unimodal, but I don't think it looks pretty. I mean, if it were me, I'd probably break it down into smaller bins so I could see. So the point of this is the calculator's histogram is garbage, okay? I don't like it. So we really need to think about either making our own histogram, which I think we're going to do here, and then we'll also, I'll show you how to do a normal probability plot. So Zachary, put your book away, please. So let's draw a histogram first. Looking at our data, what should our bins be? What do I mean by bins? The width of the boxes, the width of the bars, okay? So the smallest number is what? Let's highlight the smallest and the largest. I think this is the smallest. Who was that? Monica, I forgot. And then the largest one was Kyle. All right. So we have to think about, now the calculator divided it into, what, 6 different segments? I think we need to do more than that, okay? So maybe go up by 2s or 1s, I don't know, 46, 47, 48, 49, 50, is that too many? Probably. Well, let's do, what would 2 be? How many bars would that be? I think that would still give us around this range, right? I think we should go up by single digits. Let's try it and see if it's better, okay? So we're going to start at 46. Okay. Why is it doing that? There we go. 46, 47, 48, 49, 50. How much? I've got to go up to 50. Actually, I think I have to go up to 54, don't I? Okay. All right. So that is the weights in grams, right? So I'm just going to put my title. And then what's my vertical axis? Do you remember? In a histogram? Frequency. Very good. And I'm not going to draw a true histogram. I'm going to do a dot plot. I'm going to put a little X for everyone where it goes, okay? So let's just kind of go through the data here. 48.8, well, that's going to go here, right? Okay. 46.2, and then 47.5, 49.7, 50.6. I'm pretty spread out, aren't I? All right, let's keep going. 51. Exactly. Where should that go? Nope. It has to go in it has to go on top of one of those x's or off to itself. Is 50 included on the right or is it included on the left? On the right. So it goes up to 50 and includes 50. This goes up to 46 and includes 46. So this should go, oh, I've been in the wrong spot. Up to 50 should go right here. Does that make sense? Up to 50, it includes 50. Oh, was it 51? I thought it was 50, I'm sorry. It was 51, thank you. So you're right, so it goes right here, okay? All right, let's keep going then. Then we have 46.9. We have 50.9. 49. 48.9. 47.3. 50.7, 50.1, 49.8, 48.4, come on, 51.9, 50.8, 51.2, and 49.8. All right, what I miss, which was outlier. All right, so what do you think? It's not perfect. Would you agree with that? But it definitely is unimodal. Okay, I'm not so sure about the symmetric part. We probably need a few more Kyles over here on the right-hand side, right? But I do think that it's worth the effort to go through and test another step. Okay? We definitely can't say no for sure here. Does that make sense? All right. So let's try to draw a normal probability plot. Let me show you the steps on how to do that. We already have the data in our list 1, okay? The normal probability plot is, if you go to your stat plot, it's the very last option in the type, okay? So make sure you're changing yours. Stat plot, change your data type, and then you want to go back and zoom stat again. Okay? Tell me what you think. Do we have a definitive answer, yes or no, now? Let's see. It's kind of straight. There's a little curve to it, so it's not definitive one way or the other for certain. But what I would be, in my quest to answer the question, is the data linear, step 1 is I've done the frequency. I'm sorry, I've done the histogram or dot plot. Step 2 is I'm going to sketch the normal probability plot, and I'm just literally going to sketch it. I probably sketched it a little bit too much of a curve. Something like that. Would you agree? Just sketching it. And what information, so I've got my 2 plots, what kind of a summary sentence or something, what could we say at this point? Relatively, could be, might be, I don't know. So we need to investigate one further step. We can't definitively say yes or no at this point. Agreed? All right. So maybe it's normal. And what would I have to say? That's not enough. It's normal because, don't say line graph because it's not a line graph. The histogram or dot plot, I would accept either of those. So because the dot plot is unimodal, we're using correct words. Dot plot is plot 1, right? So the dot plot is unimodal. You don't know about symmetric. Would you agree with that? So because the dot plot is unimodal, I might say very roughly symmetric. So I'm checking that you know what you're looking for in that plot. You're showing me by writing this that you know the dot plot should be unimodal and symmetric. Okay? So address both of those in your answer. And second, what kind of a plot is this again? Because the normal probability plot is roughly linear, okay? So for a complete answer, what you'll need to do is you will need to graph both plots and address them in a summary sentence, okay? Now, the third step is the key here to really getting the correct answer. So step 3. I've kind of guided you a little bit here. It says find the intervals within 3 standard deviations of the mean. We're going to draw a picture, okay? So we're going to start with our mean of 49.8. Okay? And we're going to go 1, 2, and 3 above, 1, 2, and 3 below. What was our standard deviation again? 1.77. So let's add it. So 49.8 plus 1.77 was 51.57 plus another 1.77, 53.34. And then one more, 55.11. Okay, we'll go back and we'll subtract now. 48.03. 46.26. And 44.49. Now, think about what we can do at this point, Temerson. Once we know 1, 2, and 3 standard deviations above and below the mean, tell me what this data has anything to do with what we did up here. If the data is normal, 95% of the data should be between what and what? Shouldn't 95% between here and here? Oh, I'm sorry. Let's start with 68. You're right. You're right. So within 1 standard deviation, we're looking at 68, right? So how can I test that? I need you to wake up. I was trying to be nice about it before, but now I'm going to get angry. You need to get up. 68. What? How do I figure that out? Nope. Nope. I'm not doing that yet. Can I just count how many is in there? So let's count. So in other words, you're going to actually count how many data sets are in each of the ranges. So between 48.03 and 51.57, how many total numbers did I have, by the way? So I had what? 3, 4, 5, 6, 18, 19, 20, 21, 22, right? So out of 22, how many numbers fell in that category? So let's count. Let's cross it off. So I can't keep forgetting what the range was. 48 to 51. So 1, that's not right. 48 to 51, this one. 1, what's 51.57, right? So 1, 2, 3. Do you see what I'm doing? I'm counting the numbers that are in my range. Okay, so I've got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? Okay, so 15 out of 22, so what is that percentage?
68.
Oh, we're good. So that's 68%. Okay, that's crazy. All right, so now we're going to look at within, oops, I don't even know it's, okay, I'm almost going to do it. All right. Woo, that's fancy. All right, so that should be between what percent now? 95. There's our 95, right? So let's count those. So between 40, really? 46.26 and 53.34. Well, I already know that I have 15, right? So I'm going to add in addition to 15. So let's count now. Out of ones I haven't crossed off, what was the highest point? 50. Oh, that's all of them, isn't it? Hang on. 46 point. Anything lower than 46.26? Yes, this one's lower, right? So I have 15, 16, 17, 18. Is that one included, right? 19, 20. Oh, 21. All right, so I have 21 out of 22. And what percentage is that?
5.45%.
Y'all, we're pretty darn normal, okay? This is kind of freaking me out how perfect this is. All right, so this is 95.45%. And then between here and our last one is our outlier, or he's not an outlier, but is our lowest, is poor Monica included now in our final one? So that would be 100%. So 46.2, so that is true. So she's in our final. Now, it's not 99.7, but even though our sample, Sammy, was small relatively, we only had 22 bags, gosh, 68, 95, and 100, what would you say? Is the data normal? I think so. Okay? So that's honestly the closest I've ever come. That's pretty cool. Not me. I mean, I didn't make it happen. It just happened. But so let's recap. If we're trying to decide if a data set is normal, the first thing we do is what? Histogram. Second thing we do is normal probability plot. You know what you're looking for in each of those two things. The third thing we do is find the mean, find the standard deviation, draw the normal curve, find the intervals of 1, 2, and 3 standard deviations away from the mean, compare, count, and compare our percents. And these percents are close to the empirical rule, which is what I want you to say. So our final answer should say, I believe the data is normal because we've already addressed the graphs. Maybe it's normal, right? I think it is, right? So I believe the data is normal because why? We've already addressed the histogram. We've already addressed the normal probability plot. We're just looking at this now. What did I do here? The percentages of what? 1, 2, and 3 standard deviations above and below the mean are close to empirical rule. You can say that, or you can use the 99 whatever rule, okay? So I believe the data is normal because we've already addressed the graphs, so now we're just addressing part 3, because the percentages of the data 1, 2, and 3 standard deviations above and below the mean. If I were you, I'd write this down, because this is how I want your answer to be written on a test. Above and below the mean, or you can print it off at home, I'm fine with that, are almost exactly those percentages of the empirical rule. Now, will they always be that close? Probably not. Okay? But what would you consider close enough? How about? Come on, Temerson. Would 66 be close enough? we had I mean, it depends. I mean, it depends. If we small set of data, the further off they are, it's probably more reasonable. The bigger the data set, you better be closer, right? So you have to kind of use your judgment. Okay, I would say if you were more than like 2 or 3 percentages off, I probably wouldn't agree. Okay, almost always your last one will be 100, by the way. Almost always. Okay. So I did my answer in 2 parts. I probably think that you should, not probably, you should write both the red and the green part of your answers together as one at the end. Okay. The reason I did this is because I wanted for us to address just the graphs, but you should put this and this together in the end. Okay? Okay. Good question, actually. Very good. Thank you, Brenda. Anything else I can help you with? Okay. So your homework is going to be this and a couple other things from the textbook on normal curves, okay? So let me figure out what those are going to be. Ooh, we're done early. That's nice. You have time to work on it in class. How exciting. So I'm going to give you some problems, but I'm going to change some of the way that the questions are asked, so make sure that you're aware of that. So this is going to be chapter 6. Okay. I am going to have you, oh, you know what else I want to do? I'll have to wait till y'all take the quiz first. Never mind. I want to address the extra credit. But I'll do that next week. I'm going to have you guys do number 7. Number 8. Number 18. 21. And in problem 21, I only want you to do is the data normal. Does that make sense? So you're not going to do what it asked you to. I mean, it gives you the mean. I mean, you can, but by addressing this question, you're going to answer all A through D anyway. Okay, you're going to do what we did with the M&Ms on question 21, all of it. Okay, and then I want to give you one more. Let's do 30. I'm going to give you one more, sorry. Oh, I'm going to give you 2 more. I am a liar. I hate when I lie to you. 35. Not all of them are. Sorry. I'm trying to find one, the unusual question. It doesn't. Oh. Nah, we'll stop there. All right, there you go. Okay? Come grab a book.